Okay, so energy efficiency, and how do we define energy efficiency? There's energy efficiency on the supply side and energy efficiency on the demand side. The supply side is basically how we convert raw forms of energy like coal, gas, oil, solar radiation into a useful form like heat, electricity, and motion. The demand side is how do we use that useful form of energy. We currently convert our raw energy into useful energy in many electricity production systems and in propulsion systems, the system we use to move, while rejecting about 45 to 75% of the original chemical energy in the fuel. In other words, we only take advantage of maybe 25 to 50% of the original raw energy in the fuel. There is no reason why we cannot drop this waste into maybe 20%. Hence, by perhaps doubling the efficiency by which we convert the raw energy into useful energy. Physical laws do not go against that. We know that we can get there if we engineer systems better. So on the conversion efficiency side, I've worked on several areas, and I'll give some examples to demonstrate what we mean by better energy conversion systems. So most of our electricity production, heat production, and motion currently comes from using combustion-based systems. And there is significant room for improving these systems to achieve this improvement in the efficiency I referred to before. For instance, we worked on pressurized combustion systems for coal power plants that improved the efficiency of these plants by about 10%. We've shown that this can be done by doing several levels of analysis, and we worked with industry, and also we worked with the government for putting resources together to demonstrate that this technology can be scaled up. Alternative to combustion systems, there are other ways of converting the chemical energy in fuels to electricity. These are called fuel cells. We had been working on hydrocarbon-based fuel cells that use ordinary fuels. Most existing fuel cells use hydrogen. Hydrogen is not really a fuel. It is an energy carrier that's produced from another fuel or from another source of energy that has some challenges in the production, transportation, and storage. Fossil fuels, on the other hand, hydrocarbon fuels are more available, and we know how to handle them better. So fuel cells that use these hydrocarbons directly and more efficiently would serve the objective of achieving higher efficiency readily. We're currently working on fuel cells that use coal directly. Why coal? Coal is available in developing economies like China and India, and these economies are going to use that source of energy to develop their societies, and they need to be able to use it in ways that takes advantage of the primary energy source and that coal. We're currently working with our partners in China to get this technology to a stage where it can be demonstrated. We're also working on other ways for using coal. Instead of burning it, we're working on gasification technology to take the coal from its original form and turn it into a gaseous fuel or a liquid fuel. This gaseous or liquid fuel can then be used either for transportation purposes or for electricity generation. As it turns out, that using coal in a gasification environment, especially the lower quality type, that's again predominantly in developing countries, significantly reduces the pollution produced by burning that coal. So we have been working on new gasification technology that allows the separation of most of the pollutants in coal, in particular particulates and ash. And this is a big problem, big source of pollutions in places like China and India. We're working on separating this ash before we actually can burn the coal to clean up the products of combustion in a significant way. We're also working on technology for what we call cogeneration. So when you burn fuel to produce electricity, as I said before, you end up rejecting somewhere between 45 to 75% of the original chemical energy in the fuel in the form of waste heat. And instead of doing this, we can capture this waste heat and use it to heat up buildings, or to heat water, or for some industrial application. This way we can raise the utilization efficiency of the original fuel energy significantly. These are called cogeneration plants, and they're basically more suitable for what we call distributed generation, where I can put one of these plants in a place like MIT, which by the way has one already, where we generate our own electricity, and out of the heat that's left out, we heat up our buildings. We can even use the same heat to cool the buildings using chilling technologies. Spreading the use of this technology by making it cheaper and simpler will raise the utilization efficiency of fuel consumption significantly. This is always a win-win situation. On one hand, you reduce consumption of resources. On the other hand, you also reduce the emissions that come from burning these resources. I can give some more examples on cogeneration and multi-generation later, but the idea behind it is to be able to take one source, one unit of energy, and use it in multiple functions to produce multiple products in the same place, in the same location, so that we essentially utilize all the primary energy that was in the fuel.